Look at this big boy. From the Big Rock Candy Mountain and all those other things that famous YouTubers say. Got this from eBay. They're very inexpensive. They come with a bunch of inserts. This arbor detaches from this head, just like every other. And we'll just see what the hell this mill can do with such a beast. What this beast can do. Or if it is a beast at all. Maybe it's just a big, neat-looking piece of crap. I do this for you guys. Okay, so first let's talk about what we did here. This tool comes with a 3/4 inch shank. A straight shank. A lot of times these tools will come with their own holder, either an R8 that fits right into an R8 spindle, or, you know, Cat 40 tape or something like that. This one came with a straight shank, which is actually super awesome for us guys using the TTS system. It's 3/4 of an inch, which is the size we need. And then it's got this flat reference shoulder right here. At least that's how it comes. So what you saw me do is relieve this face just like all the TTS tool holders. They need this so that there's room for the collet to move around in there and clamp on as tight as it can and really pull this surface up against the face of the spindle. We didn't do anything that would change the stability of the tool, the geometry of the tool holding, or any, you know, concentricity of how it is held in the spindle. That's something you need to know when, you know, even considering working on a tool such as this, is that any change you make to the important geometries, which in our case is absolutely this one, and then secondarily is this one, we'll get to that in a second. But as long as we leave those alone, we're not really playing with fire. I also shortened this shank just to fit up in the collet a little bit better. It makes tool changing a little bit easier. The difference between this and any TTS holder is that on a TTS holder, this is properly ground perfectly perpendicular to this surface, to this entire axis. That way, when it is put into the collet and it references up against the spindle nose, you get the same contact no matter what orientation it's in every single time. This, we are not guaranteed that. I don't have a terrific way of measuring that I can think of now. Anyway, this is not a ground nor hardened surface, so it's not going to be as theoretically perfect as far as a repeatability sense when we insert and remove the tool every time. It could vary up to a couple of thousandths of an inch. Tool comes out. Tool goes in. Just under 6. No. About a 50% step over. A little bit of vibration there on the left right. I think I need to sort out some gib issues with the X axes. I think. that's really cooking. That's like 24 inches a minute. That's 8 inches a minute. About halfway through, spindle bog down. Let's see how slow the jog is. Okay. Had a little interview or interlude with a pulled out tool. You probably saw that on camera. Anyway, tightened up the collet, and we're still well within. It'll still pop it out, the tool changer will. So maybe that was accounting for some of our issues we were having on the last cut. You can definitely see it. That looks really funny. Anyway, so changed our depth of cut from 100 thousandths of an inch, 0.100, to 50 thousandths of an inch. So we've cut that in half, but we've doubled our width of cut. So now it's 200 thousandths of an inch, 0.2 by 0.05. Once ago, now I'm at 0.200. When your camera dies and you're just like, what? Okay, welcome back. I don't know what all you caught, but we're doing really well with 250 thousandths of an inch step over, 50 thousandths of an inch depth of cut in cold rolled steel. And I'm pushing this cutter at 11.5 inches a minute at 1500 RPMs. And it's going really well. There's what looks like there's a haziness on the floor of the cut that could be possibly from rubbing. I'm trying to get it to take a nice big healthy chip and also minimize vibration. And I had an idea. So this little wall right here, this remaining part of this 1 inch by 1 inch cold rolled stock, this should be 0.200 wide, and off this current wall should be 0.100 deep. So I took the cutter back across what was left here, and that was a 300 thousandths of an inch little shelf on this side, and that was 50 thousandths of an inch tall. And I just basically centered the cutter over the workpiece so that we were leading with the center of it and not just trying to catch it on its edge. And it threw chips everywhere that way. Whatever. Went at 11.5 inches a minute and 1500 RPMs, and it did really well. It cut nicely. You can see the surface finish is really quite nice. I'm leaving fingerprints all over it. It's got an extremely sharp edge, as mentioned before, with the burrs on either side. Okay, so what did we learn from this? A few things. We learned some good feeds and speeds that it likes, and what it doesn't like, what the spindle likes, what the spindle doesn't like. And generally, what we're dealing with as far as like finish and things of that nature. What I learned about the machine is that the spindle, if we're going to be running a big tool like this, we need to run the spindle at as much power as possible and then gear the tool down. With aluminum, you know, it seems to be able to handle the higher speeds pretty well. I was doing 2,500 RPMs without an issue and taking some pretty good sized depths of cut. When I moved over to steel, however, I noticed that the spindle just could not make that much of a cut at those speeds with this cutter. But once I moved it into the low gear setting and pushed the motor itself, and that's the weak point here, is the motor itself getting bogged down. Very simple, straight DC motor. If we were able to drive the motor at its full power and have the cutter moving at a speed that's more rated for the material with our surface feet, we were getting great cuts and getting a really good material removal rate. About 1,500 RPM on the cutter. That's running the motor at about 100% of what I've got it set for. And taking off, you know, up to, I think I did, the biggest cut was 300 thou over and 50 thou down, or 200 thou over and 100 thou down. The latter was at 7 inches a minute. The former was at 11.5 inches a minute. And we're getting a really nice surface finish here. I was getting a little bit of tool pullout, and I do have a tram issue. There were other things I learned about the machine in this little experiment. So I think as far as just a nice material removal tool, this will do really nicely. Something about like running something like this versus say like a 1/2 inch roughing end mill, something of that nature. If this breaks, I just have to replace the insert. That's a lot cheaper than having to replace an entire 1/2 inch end mill when a flute breaks or the whole thing snaps in half. That is kind of nice. I do like that feature. These inserts are a little bit less expensive per each if I was only to break, say, one. They can obviously be had extremely cheap if you get this grade of insert that it comes with. But I can also stock them on hand and change it out and be ready. I don't have deep enough pockets or tool cabinets to keep that many large carbide tools for material removal. So if I break one on an operation, you know, not only does it set me back money, but it sets me back time. I've got to order one. And that's all, you know, part of growing the shop and everything. So some other thoughts with this is that it, being wide as it is, something I've not really put a lot of thought into before on my machine, but you run out of y-axis travel. And you can run out of, I mean, if your machine, depending on your machine and how it's set up, you can run out of axis travel in any direction because it's so wide. I hadn't really noticed it before. I usually, you know, use relatively small tools for relatively small parts, and having to try to do something like an adaptive clearing setup to cut a feature out instead of just a simple facing operation, to try to get to the back side. Of a relatively large part, you might end up bottoming out your y-axis in either direction. My machine, you know, I've been pretty honest with my thoughts on its capabilities and its performance, and one of the drawbacks that I don't feel like I've touched on too much is the fact that it's only got about 6 inches in the y-axis travel. Once you have a vise and all that on there, it lists 7 in the manual, and I don't think I've ever gotten 7, maybe if you really ram it into the column, but I try to keep a little bit of clearance so I don't run the vise into the column or anything like that. That's something I noticed trying to do some adaptive roughing with this, and it led to some interesting setups which ended up working out just fine, but sometimes you have to rethink how you're doing something. And this is something that I would have never thought of going into it, and that's a problem that, I'll be perfectly honest, I didn't think about when I ordered this and even when I started using it, that it would be so big that it would actually max out the limits of the machine, the physical front and back. The cutters, they don't really feel sharp. The inserts, they, you know, and these don't, I mean, they don't come out usually razor blade sharp when you get them, but I don't know, they're also, you know, like completely no name, no provenance of any sort. They're just the cutters that came with it, you know, in its unremarkable packaging. I only say that, I got good cuts, but it did leave burrs, which I think is part and parcel for the tool. The nature of this tool is we're probably going to get a pretty wicked burr, but it seems, it reminded me of cutting with a relatively dull end mill. If used gingerly and judiciously, I think it'd be a pretty decent little material removal tool. If not, it looks really cool in my tray of tools with all the other stuff sticking up. Makes me look like a real badass, right? And that's really what it's all about at the end of the day. Overall thoughts and opinions on this. Like I said, I'm not trying to do a sales pitch or really even a formal review. I just wanted to play with something and see if my mill was capable of it. So, that in mind, you know, it works. I was surprised how well, so far, the modifications to the shank. I don't know how that could fail, other than, like I said, this surface right here not being perfect. Given that, everything else works really well. I had to get the collet tightened down because it's such a big cutter and it really wants to pull. So if you do have a setup like mine where you've got a quick change drawbar, or if you're using a TTS collet just in manual mode, or even just a 3/4 inch collet, you're really going to want to grab onto this thing. Really give it the muscle, which makes sense because it's a big freaking cutter. It moves a lot of material. It's no slouch. You know, the spindle motor is the weakest link when it comes to moving this thing. I was getting a little bit of vibration at certain speeds and feeds, but the biggest failures I noted was the spindle motor just bogging down and stopping. Using the speeds and feeds that we played around with just jogging this through some metal and setting up an adaptive routine in steel, Fusion was telling me I was getting like 11 thousandths of an inch per tooth in this thing, which is really impressive compared to what I use for all my other tooling, which is more like 1,000 per tooth, maybe 2 in aluminum. Hope you found any value in this. Be sure to subscribe if you haven't. Check me out on Instagram. And if you really want to, go check out Teespring and Patreon. Those directly support the channel and help me to keep trying silly tools in my silly machine, just like this. Have a wonderful day.